So I'm going to talk a little bit about some research that we're doing at the Colorado Basin River Forecast Center. We're located right here in Salt Lake City, just very close to the airport. So, I would say this presentation, we're going to talk about a particular research project that we're doing, but there's lots and lots and lots of stuff that we do at the Colorado Basin River Forecast Center that potentially we could help you. So just because this might not be right up your alley or might not have an immediate applicability to your office or to your work, let's talk. My whole job, they gave me this fancy title, Service Coordination Hydrologist. My whole job is just to reach out and talk with people, understand what your needs are, and how to work with you. So I don't know, it should be like Paul Miller, professional talker, or professional go out and meet people. So so that's what we're talking about today. And sorry if I have a little bit of a cold, so I'll try and project. But just special thanks to Andrew Verdin at the University of Colorado. He really did the development of this tool that we're going to be talking about today. He got his PhD using this tool in Argentina. And Janelle Hakala, who is she's a senior at the University of North Dakota. And if anybody's looking to hire a motivated young student that's just about to graduate, she's really good. I'd highly recommend her. But right now she's volunteering with the Grand Forks, North Dakota Weather Forecast Office. But just a couple things. So just who are we? We're one of 13 river forecast centers. Oh, great. Pointer works. This is our entire area. And luckily we're located, just a couple miles down the street, pretty close to the airport. We're just catty corner from the airport, Radisson, if you know where that is. But we're one of 13 river forecast centers nationwide. And I think it's really important to stress that we're an operational field office. We're all about decision support. Basically, everything we do at our office is driven by stakeholder needs, stakeholder wants. We don't just kind of do pie in the sky or ivory tower kind of stuff. Everything we try and do with an eye towards how is it going to be applicable and how is it going to be used at your offices. If we're doing something that's not needed by anybody, it doesn't last very long. So we work with a broad set of stakeholders. Probably the most people that we work most closely with are other weather forecast offices in the Bureau of Reclamation. When you hear in the news that Lake Powell is low and Lake Mead is low, and they might be declaring a shortage, that shortage is ultimately going to be declared based on the forecast that we provide to the Bureau of Reclamation. And I'm happy to talk about how that works more if you'd like. We work with a lot of municipal and agricultural users. We do work with Salt Lake County. They provide us lots and lots of data. Salt Lake City Public Utilities are another big user of ours. So we're really happy with our relationships with those folks. And we get just lots and lots of data from lots and lots of different folks. So just a little bit of how we work. You've probably been sound asleep in your bed at 11 o'clock at night. Your phone starts blowing up and there's a flood 80 miles away or something like that. That's not us. That's not our fault. That's the Weather Forecast Office's fault. But we do help them. When those floods are going out, we're typically looking at the forecast. We're typically trying to look at the computer models. We're trying to figure out how long is that flood going to last. How high is that flood going to be? Probably the most popular thing we do in our office, and it's related a lot to the work we do with the Bureau of Reclamation and others, are seasonal water supply forecasts. We're trying to predict the volume of water that is going into people's reservoirs, how much water people have to work with. And it's really tricky to forecast flows in the Colorado River Basin. This is just observed flows into Lake Powell. And you can see, here's the average April through July flow into Lake Powell. I don't know. You can probably count the number of times on one hand that the flow is actually even close to the average. We're usually way up here or we're way down here. So, and then too, it's not always correlated to just the snowpack. There's lots and lots of stuff going on in the Colorado River Basin. We're trying to account for diversions. We're trying to account for soil moistures, changes in temperature, changes in precip amounts and occurrences and how it's happening. So there's lots of stuff that goes into ultimately forecasting flow in the Colorado River Basin and in this general area. Just a little bit more about our water supply forecast. Right now we're really dependent on the past. So we utilize what we call an ensemble of past climate to generate possible stream flow. And basically what we're saying here is that we know what the conditions are today. Well, what happens if we take all the scenarios from 1981 through 2010, and we're going to update this soon through 2015, and we say, okay, starting from today, let's look at the precip and temperature from 1981, the precip and temperature from 82, 83, 84. And we come up with this broad range of what our possible stream flow scenarios could be. So we come up with this big range, and we try and distill that information down into sizable chunks that people can use. And sometimes we just provide the whole ensemble to folks. We just give the whole range of possibilities and let them run with it. But the bottom line is the more information we have to better quantify our states today, the better. So just a little bit about how we generate it. It all starts with data. Again, like I mentioned, Salt Lake County and Salt Lake City, they provide us a lot of the data that we get from here. So does the USGS and the NRCS. Good data in mostly means good data out. So we're very appreciative of all that. That all goes into our hydrologic model. We do a lot of quality assurance, quality control on that data just to make sure we're not letting any bad data slip in. And then we as forecasters, we sit down at our computer every day and we're looking to see how is our model doing? Is it doing well? If it's doing well, we typically think that it's going to do well going into the future. Here's just a screenshot where, yeah, we didn't get, here's the observed, are these red dots here, and our model is this blue line. And so, yeah, we kind of missed this peak that came off this rain event here. Got kind of close to the height, but it kind of came down a little too fast. But in general, it's doing pretty well. We think it's modeling all right. And so we're pretty confident looking into the future that our model is going to perform all right. And then from there, we come up with that huge ensemble, or I shouldn't say huge, it's 30, 35 traces of possible futures. So this is what we're thinking, you know, from today, here's all the ranges of futures that we think we could see over the next few months. And we try and distill that information down. So this is just kind of what I said in a more graphical form. We've got these 30 traces. We're really looking at the reservoir levels and the river levels, our modeled soil moisture conditions and the current snowpack. And we'll be extending this through 2015. It'll be ready by January. And so we'll have 35 traces going forward. So like I said, we're very dependent on the past when we come up with these forecasts. But we know the climate's changing. Climate change is something that we acknowledge and we know is happening. We know that temperatures are rising and that they're going to continue to rise. Precipitation in the area is a bit more uncertain. We're in this very mountainous area. A lot of the climate models don't resolve the complex terrain that we have as well. But we do expect more extreme events. We do expect more intense precipitation. That 100-year storm might become more of the 50-year storm or the 75-year storm. And ultimately what we think this is going to show is a decreased water supply, particularly over the Southwest and in the Great Basin and the Colorado River Basin. So in addition to the climate needs changing, our stakeholder needs are changing. In the past, people just wanted to know, what is the forecast? What's that one number that I can base my decision on? How much water is there? How much snow is there? Will there be flooding? Will my reservoir fill? Yes or no? They just wanted to know, tell me what to do. But we're changing where we're going. People want to know more of what is the range of the forecast? What's the likelihood of reaching a particular flow? Folks are much more interested now in their uncertainty and their risks going forward. They want to know what happens if we get 2 or 3 more dry years. What happens if I get a wet year coming up? They really just want a better understanding of where our uncertainty is and where the risk is to them. So, you know, we're very, very reliant on this past data, but we know climate's changing. This whole idea that the past represents the future, that's just not going to work anymore for us. So, like I said, stationarity is in the past, but right now it's how we look forward. This is currently how we make our forecasts, is by looking in the past. What about extreme events? You know, because we look in the past, we rely on past precipitation patterns, past temperature patterns. these patterns are going to change. So is there a way that we can start to leverage climate information that's out there into our water supply forecast? And so that's where we get into Andrew's work at the University of Colorado and using the stochastic weather generator. We're hoping to reduce our reliance on historical weather and climate information. This will allow us to understand our variability and risk better, and hopefully incorporate climate information going forward into the future. So again, developed at the University of Colorado. There's some fancy statistics on here. Nonparametric uses a k nearest neighbors approach. Basically, this is saying that it doesn't assume that weather and climate is going to fit that normal Gaussian distribution that probably killed you in school, right? Somebody would blow the curve for somebody. This approach doesn't use that Gaussian bell curve. It's more appropriate for weather events, especially in our area where we get these kind of highs and lows with regards to precip. It's spatially consistent, so it does use history to come up with historically consistent things. For instance, you're not going to have, the wettest winter ever in the Bear River Basin and the driest in the Logan River Basin. And so there's a couple papers that you can go and look at if you really, really want the technical details. The big takeaway from this is that they've been able to use this in other parts of the world, not necessarily the Colorado River Basin, but they had some success in Argentina, and Leanne Daughtry, who was doing her master's work before Andrew, she applied it in the San Juan River Basin, which isn't too far away from us, and also found some success. But all these graphs and stuff are showing is just basically that, yes, we can improve our forecast a little bit if we start to bring in some other outside climatic information and not just rely on the past so much. So some of our initial results, this is an ongoing study in our office. So there's not a lot of finality to these results yet, and they're still very provisional. But what we did first is we ran this unconditioned. We ran this without incorporating climate into the model. And we just wanted to answer the question, are 30 traces enough to capture the variability that our stakeholders are asking for? And so what we did was we looked at the Gunnison River Basin. This is the East River at Almont section. And what we found is that we're capturing much of the precipitation and temperature variability at 30 traces. So we're at least really happy with that. When we tell people, hey, you've got a 10% chance of exceeding this particular amount or 50% chance of meeting this particular volume, that we're telling them good information. So we ran the model with 3 traces, 10 traces, 30 traces here in green, which is currently what we operate at, and then 50 and 100 traces in the orange and yellow. And you can see the oh, sure. So when I'm talking about traces, I'm just talking about right now in our office, when we say a trace, we're talking about the 1981 trace or the 1982 trace. So right now we're just confined to 30 traces of historical data. The cool thing with the stochastic weather generator is we can have as many traces as we want. We can have 30 traces, or we can have 100 traces, or 1,000 traces, or 3 traces. So we're not confined to just the past. We can come up with as many traces as we'd like. And one question, like a lot of our stakeholders had, was, you're using 1981 through 2010. Is that really representative of what's going to happen in the future, or does that capture the variability in the system going forward? So great question. And so what we did with this weather generator was we came up with, so we ran it with 3 traces, 10, and then 30 traces, which is our current operating procedure, and then 50 and 100 traces. And for the most part, aside from a few outliers here and there, we're pretty confident now. There are some areas like August where we have a bit more variability here. The median kind of matches up a little bit closer with the 100 than with the 50 for some reason, but the entire range is pretty consistent there. We're pretty confident now that 30 traces is at a minimum enough to capture some of the variability going forward. We're starting to add more years to our historical record. So like I said, by January, we'll be going through 2015. And so we'll have 35 traces. But we're confident that we're explaining some of the variability, capturing some of the uncertainty in our forecast. The results were even better for the maximum and minimum temperatures, not as much change in the variability once you got past 30 traces there from month to month. So we did use some conditional results, and we based this off of Climate Prediction Center probabilities in the upper Bear River Basin. Right now there's a little bit of a coding error, so don't pay attention to the numbers, just pay attention to the picture. And I know where the error is, I just need to sit down and fix it. But so here's the Bear River Basin, and these numbers right now are unreasonable. They're off by a order of magnitude. But the really cool thing for us here is with this weather generator, we're able to be spatially consistent. In the past, weather generators would say, hey, I have to look at this area, and then I have to look at this area, and then I have to look at this area. And even if there's a correlation between the areas, that correlation wasn't picked up. With this weather generator, it's able to say, hey, I'm going to take in all this information at once, and I'm going to make sure that my generated sequences or my generated traces are spatially consistent. And so you can see here, we're not getting huge variations between our temperatures, our precipitation amounts here. There's not big jumps in the values going from one end of the Bear River Basin to the other. This is really encouraging to us. It's a pretty simple error that I can fix, and so that's going to be coming in the next couple of months. So that's our next steps. We're going to fix this coding error. Right now we were just plucking, I don't know if any of you have gone to the Climate Prediction Center website. They put these big maps saying chances for above, below, or normal values. And we were just plucking one number off to see how we can get this thing to work. We're going to use those values more robustly. We're going to figure out how we can take a more spatially representative forecast from the Climate Prediction Center to weight the model a little bit more robustly. And then we're going to verify this. We're going to run this in the past. We're going to take this tool, we're going to run it in the past and see if we could have done better in the past using this tool compared to how we've always done things. So with that, I'll open it up to any questions. I know there's lots of, we can get really technical with this. It's very statistics driven, very technical with regards to statistics. But I just wanted to give you an overview and a bit of a flavor of what we're doing, and we can go from there. Hi.
Those climate prediction maps are using things from outside the area.
Yep.
Like the law.
Right.
Back.
Yep.
Are you also using that kind of information, or are you strictly running off what used to happen?
So right now we run strictly off of what used to happen. And that's one of the big benefits of being able to bring in information from the Climate Prediction Center is that they're taking into account things like the ENSO cycle, things like the Madden-Julian oscillation. Being able to bring in some of these larger teleconnections to make more informed precip and temperature forecasts, we think that's going to be a big benefit.
So you're using past statistics to predict future statistics?
Yes, we are. Yeah. So and that's the big problem right now is we don't think the past is going to represent the future anymore with climate change and with a lot of these other problems that we're facing. So so right now we're just relying on the past, and we're hoping that we can capture some of that variability. But going forward, we'd like to incorporate some more larger scale information, especially with regards to climate. Yep.
I think Great Salt Lake serves as one of the biggest reservoirs of water from our watershed. Are you predicting how much water is going to flow to the lake?
We do make a forecast for the Great Salt Lake. So yeah, if you go to our website, we do have a forecast for flow into the Great Salt Lake. Yeah.
So in your models, are you able to put in these multi-decadal type of oscillations that influence the precipitation, or is that kind of still too unknown or uncertain to be able to put that type of information into it?
I wouldn't say it's a matter of it being too unknown or too uncertain, but right now we don't incorporate that information just because we just rely on the historical patterns. We have a really old hydrologic model that was developed in the 70s, and it really only gets run out on the order of about a year. And so most of the time, these big decadal oscillations don't have a huge impact on the year-to-year stuff. The one that tends to have the biggest impact is El Nino. And we do take that into account a little bit when we're doing our lower basin forecast. But up here in the Great Basin or the Upper Colorado River Basin, the correlation just isn't there with a lot of skill to say, oh, it's an El Nino year, it's going to be wet or it's going to be dry. We just don't have that kind of skill right now. So we don't currently incorporate that right now. But this weather generator would help us incorporate more of that climate information. Yep.
Do you forecast temperature and precipitation separately? So, what I guess what I'm trying to get to is, do you look at the effect of temperature on flows in rivers with increased evaporation?
So the short answer is yes. so we get short-term forecasts of precip and temperature from the weather forecast offices. But once you get past about 10 days, those forecasts become very uncertain. So we rely more on climatology. So we start looking more at the 1981, 82. We start looking at the historical precip and temperature. Our model does change evaporation in response to temperature. So yeah, that's how we adjust for. So if things look hotter, we'll see increased evaporation. And our model also models use in the basin, in some areas of the basin. So with changing temperatures, we'll forecast more consumptive use for agriculture also. So good question.
Is there other methods besides looking at the past to predict future weather?
Oh, there's lots and lots of other methods. So this is one of them. Using a model like this is one of the methods to you still kind of look at the past, but you're more using the past to come up with sort of patterns or looking at just like the magnitude of events. So this is one method that we can look at to look at the future differently. There's lots of other stuff. There's stuff that doesn't rely on historical data at all. There's climate models and weather models out there that they don't care anything about the past. They're just looking totally into the future.
Predict global warming events?
Yeah, there's climate models that totally predict global warming. That's how we kind of know that global warming and climate change is happening, is that we can use these climate models to look at the impact without man-made emissions and look at the impact with man-made emissions. And if you're super interested in those models, you and your parents, you're welcome to come down to our office, the weather forecast office, anytime, and just walk in and we'll show you all the weather models and all the stuff we do. So I think I have 1 minute left if there's any last-minute questions. But yeah, I showed just a very small part of what we do in our office. I really encourage everybody to go to our website. It's cbrfc.noaa.gov. It's going through a lot of improvements and changes right now. And if you have any questions, really, call me, email me. If I don't get any calls in the week, they just let me go. They just say you're done. So. Sure. Website again, CBRFC, so Colorado Basin River Forecast Center, .noaa, NOAA.gov. And yeah, tons of information on there. We don't even put all the information that we have on there. So if you don't see something that you need, let us know.